Recording. Now, hopefully we are not plagued with like a horrible feedback. I'm just going to rely on the system's, clipping to, because I don't have head handy.
All right, I'm going to go ahead and log into the website, but I have to tell you in advance, I'm having a conflict in scheduling right now because I have some family members in town that said, "Hey, let's have lunch." I said, "Fine, no problem." And then all of a sudden, they call me like right when you send me the meeting. "Hey, we're almost there. We'll be there in 2 minutes." It's like
Hmm.
they were supposed to give me, like an hour notice, and now I'm like, oh. So
I
anyway,
I confused you because I wasn't even talking about that. I was just going to engage you with something really random.
oh, okay. I thought we were going to do a little tutorial on this app. Go ahead. Let's go
We
for it.
all right. So, man, I'm gonna have to email you the link really quick.
Okay.
And let's see, where's my screen? Here it is. Boom. I'm going to share this screen with you. Let me email you the link really quick so you can pull it up.
Are you in your new house? No? Yes?
No, no, no.
No. No.
Hopefully 1 year, 1 year. Next year, for real. Let's see. Okay. Share screen. How do I do this? All right. I was thinking about portals the other day, and then this story popped up. And so I want to get your feedback on this. I haven't really digested it. I was like, oh, what a cool news story. And I said, well, let me just share it with James and we can just chat through it randomly. Um, I don't know if you
Send
could.
me the link. Send me the link on Signal so I can look at it on my computer instead of trying to deal with it on the phone. Oh, I see. But you want to share it, so you're recording this. Sorry, I'm messing up your
That's okay.
recording.
I have it shared here, but I'm going to send it to you also in Signal right now.
Okay.
And I just scanned this article. I haven't really digested it, but the work we've talked a lot about magnets and things. And
Oh yeah, yeah. I sent you this article. This is cool. I watched more videos about this. Now, this is a very, very awesome topic. Do you want me to start, or do you have a
no,
specific questions?
I had no idea you were aware of this. And if you send it to me and it just buzzed over.
Yeah, yeah. I sent it to you a couple of days ago, and what was because it was we were talking about the mag vice, and I thought originally when you had it that you were going to do some biological things and see if you could align the ferrites in the cells and things like hemoglobin and whatever to get different kind of reactions. And you were like pointing your laser and they're saying, "Oh yeah, it's bending the light," and I'm like thinking, "No, that's not how light and magnetism works, right?" Because again, that's what they've taught us for years, and I've never seen any evidence. It's not like you can take a light bulb and a magnet and see some kind of reaction to it, right? So it seemed self-evident that there was really nothing going on. And anyway, so this article pops up, and I'm like, "What? This is the craziest thing ever." So they said that what happens is this Faraday effect will cause light to twist. And remember, we were talking originally about the excess core and all this dovetailing of quantum physics and stuff like that. Well, what this magnet will do is cause the polarization of light to twist. And they found that infrared light will twist as much as 70%, which is, I mean, that's amazing. We're not talking, I guess 100% would be 180 degrees, but this is still like, I mean, I can't even tell you the applications that are going through my mind of how you can encode data. And even for us with our excess core technology, if we were to use infrared and modulate it with a magnet so that it's twisting, I mean, I can't even envision the kinds of things that we're going to be able to achieve with this information that they've come up with now. But yeah, it's mind blowing. And 70% twist is just, I would have never guessed. And I think that we're going to have to make some really cool experiments pretty soon to test it out and play with it.
All right, let me ask you some of my layperson questions to see if you can respond. So does this mean that light has interacted with the magnetic field, but meaning like on a micro scale? So we would need massively powered light more than we have in our household to see this effect happen. Is that kind of what?
No, not at all. No, I think it has to do with, I don't think the power of the light has anything to do with it. It has to do with the orientation of the field. Okay. So if you think like, I think you even sent me a picture of it. It showed if you take a wave a magnetic wave, and like we see the traditional sine wave, like a 2D dimensional representation of it. And then they show you, well, when the electricity is going up and down 90 degrees out of phase in this other dimension, 90 degrees in three dimensions, we see the magnetic uh, uh, wave, which corresponds with the electrical. I mean, it's not exact. Like the electric goes up, and I think it's 90 degrees out of phase. So, anyways, someone showed me an image of what that looks like when you tilt the whole linear two-dimensional thing, and you look at it axially. It looks like a mandala. Okay, so different frequencies create these different mandalas on end, which is so if you can visualize that in your mind and say what will happen if we add magnetism to a light beam, and you look at the energy coming directly onto you, it will spin, it'll twist like this. So it doesn't matter how strong it is, it's twisting that light. It doesn't matter if you put in 10,000 watts or you put in a half a watt, the magnetic field is going to twist it. Now, of course, the stronger the field, the more the twist, but that should give you an idea how that works. So it's not necessarily the light, but it is the magnetism that's interacting with that light.
Okay, I'm following you. So the inverse then should be possible. A light could alter the magnetic field as well, right?
This is true. Yes, a lot of things in physics have a bidirectional or bidual. I don't know what you want to call it, but yeah, it's like you can take light and make electricity. You can take electricity and make light. Vice versa. We know that electromagnetism will make electricity and vice versa. So, yeah, there's a lot of things in that, and absolutely, I believe that the light twisting can change the magnetic field. So the question is, how do we make the light twist?
Yeah, yeah. Well, you already know where I'm going with this. My mind's already off into like, the ET beam that picks up cows and stuff in the superpower light. And it's like, wow, it's like I love when we have like new physics things that suggest other stuff could be true or could be, more palpable. And I was thinking about portals this morning and thinking about the Bigfoot whole stuff and these people who, a lot of people who see Bigfoot, they say they saw a portal and he climbs out of the portal, right? It's like jailbreak, but in theory, it seems like that would be it, right? There'd be some type of light that I don't know, rips open
Well,
this.
yeah, and considering the fact that the frequency makes a big deal, and they're finding that other frequencies have this property too, but right now, infrared is the one that's showing the most promise. It reminds me of this physicist. It might be this guy here, Randall. I forgot his name. It was uh, anyways, this physicist, yeah, this is him, Randall Mallet. What he does is he takes lasers and he points them so that they make a spiral. And his theory is that if you have these things aligned properly, you can alter time. So you can make a time portal like what you're talking about. And I was thinking, right as soon as I heard that you can change the twist of light with a magnet, I was thinking, wow, this is right up Randall Mallett's alley. And he might not even be thinking of twisting the polarization of the light. That might be the key. I mean, he might be on the right path, but he's not looking at it the same way that I'm looking at it. And that is that we should try to twist the light instead of physically making mirrors bounce and make a spiral. Well, it's already got the capacity to make a spiral end within itself using magnets. So maybe there's a possibility to make a time portal with a laser and some and very powerful magnets. That's just the illustration in the article here almost sums it up right to itself. I think that's kind of cool.
Did you see the video? I think I sent it to you about the guy who he modified a camera so he could see, every individual photons and he shot it and he was in his garage and it went off the
Yeah.
mirror.
Hmm.
Came back faster off the mirror. I don't think he explained it. I think he ended his video saying if anyone has any ideas why did the light move faster after it hit the mirror. But to your point, that's kind of like a vortex type scenario that perhaps if you twist the light.
You have to remember what he did was kind of a sleight of hand because he was sending strobes of light at a I think it was a picosecond strobe and then recording it so that just like when you look at a fan and you strobe a fan, like if you had a strobe light and you strobed a fan or a record player, it would look like it's moving very slowly because you're strobing it. So he was collecting those light samples as they were strobing through the house, and that's why it made it look like he could follow the path. I mean, he literally was. It just he strobed it, so it was kind of a sleight of hand. And I'm sure that when it hit the mirror, it was probably because it was out of sync. You know, it was like it was strobing at a different rate when it came off the mirror. Maybe it slowed it down a slight bit or something. But that would be my explanation for it. But yeah, it's really cool to see people do that. You know, when you see it happen and you see the light go through an ice cube and all that stuff, you're like, what am I looking at? It's pretty
Um,
cool.
the other thing I wanted to ask you is, did you have any feeling as to why it would be like I've quoted the part here, 17% roughly, but then 70 in infrared, three times as much twist.
Yeah, it probably has a lot to do with the magnetic field and the harmonics of the frequency itself. Like we were saying, if you're looking at it spirally like the mandala, right? You can't always fit a frequency around the peripheral of a circle so that they match up perfectly. You know, some frequencies are going to overlap and probably cancel themselves out, so you only get a little bit of that change. But if you have frequencies like in the infrared range that when they go around, and you again, we're looking down axially down this wavelength, it's spinning, right? It's twisting like this as it goes down. Those things probably create a constructive and destructive polarization mode within itself. I mean, that's just my conjecture on that. I don't really know because I don't study optics as much as I should, but I take what little bits that I get and I can make conclusions from them just like anybody. So
Yeah,
that's my conclusion.
interesting being that like humans and we emit infrared, right? And that's what's having a greater twist here. That's an interesting
It
correlation.
is. Yeah, it's in the realm of life, but it's just outside of our natural spectrum that we see in, which is, I think that was a one of the reasons of why it was such a mysterious um, phenomenon because we didn't see it. We're kind of we like to see what happens. If we can't see it, we don't think it exists. So that's probably why for 180 years this technology went through the cracks of the floor because we just assumed it wasn't working because anybody can take a light bulb and a magnet and see that nothing happens. So
Right.
that's
Yeah.
probably where
Well,
that
I
is.
mean, I stand by what I saw on Magvice, but I want to refresh the magnets and do it again because
Yeah, try red ones too. Try red lasers and see what happens.
okay, yeah, definitely cool. Well, I didn't mean to interrupt you too much, and thanks for
No, no. We're good. I wish I wasn't like under the gun. I'd love just sit here and shoot the crap with you all day long on these things. We got all kinds of stuff to talk about.
well, have a good day, James, and thanks again.
All right, man. See you later.